Welcome to episode 2 in our mini-series Solving Trig Equations. So in this little mini-series, the questions are going to get increasingly more difficult as we go through. So I always recommend watching them in order, watching the first video first, and then kind of moving your way through them. So in this video, we are going to solve this equation here. What I notice is that I have a tangent, and I am going to make the stipulation that we only want answers between 0 and 2 pi. So I don't care about any answers outside of 2 pi. So in this one, we are not going to have to add or subtract 2 pi n. We are just going to look for the answers that are between 0 and 2 pi. So what I notice is I only have one trig function, which is great. And I actually only have one term with that trig function. And so if I only have one term with an x in it, I just want to start peeling things away from x. So the first thing that we should do is we should add 1 to both sides. And so we're going to have 3 times tangent squared of x equals 1. We're going to divide by 3 on both sides. And so we're going to have tangent squared of x equals 1/3. And then from here, some of you might say, well, what the heck do I do now? Well, remember, this is just tangent squared. So we are trying to isolate the x, but we have to isolate things in order. And so we're trying to get tangent alone so that then we can do the inverse tangent. Well, right here, we are going to square root both sides. Now, there is quite a bit of algebra that comes into play here. Whenever you square root a function, you get both the positive and the negative. So we now have two equations that we are solving. We have the positive and the negative. Well, furthermore, there's more algebra. This is actually the same thing as the square root of 1 over the square root of 3, which means this is the same thing as negative root 1 over negative root 3. The square root of 1 is just 1, and I don't know what the square root of 3 is, so I leave that. But we are not allowed to have a radical in our denominator, and so we multiply by root 3 over root 3, and we're allowed to multiply by that because that's just 1. This is called rationalizing your denominator. You first learned about how to rationalize the denominator in geometry. Then you did it again in Algebra 2. And then we spent a little bit of time this year as well. 1 times root 3 is root 3. Root 3 times root 3 is root 9. But root 9 is just 3. So we are looking for when tangent of x equals this or that. Now remember, to get rid of a tangent, you're going to inverse tangent both sides. So we are looking for the inverse tangent of both of those things. So we're going to take our handy dandy little cheat sheet here, and we're going to go to the tangent column, and we are going to look for any time we see a root 3 over 3 positive or negative, and we're going to write our answers in radians. The first time I see it is right here. So that's going to be x equals pi over 6. You notice I'm in that tangent column. Then I see 5 pi over 6. And I hope you guys start to see a pattern that when you go through these values, your denominators are all going to be the same. I'm still in the tangent column, and I get 7 pi over 6. Could anyone guess what the last one is? There's only one more over 6, and it's 11 pi over 6. So those are all of the answers that we get for when these two equations are equivalent. Could you check your work? Oh, absolutely. And should you check your work? Anytime you can, you should. That's not going to work out for me. All right. So my first equation that I'm going to type in here is going to be 3 tangent squared of x minus 1. And then I'm going to type in 0. I also like to put in that x equals 0 and make this a dashed line, and x equals 2 pi and make this a dashed line because we only care about the answers between 0 and 2 pi. And so I'm not going to look beyond this point. So here are my answers. The first one is at pi over 6. The next one is at 5 pi over 6, 7 pi over 6, and 11 pi over 6. Of course, there are infinite answers, but this next one is beyond my dashed line. It's beyond 2 pi, so I'm not going to write that down for my answer because it asked just between 0 and 2 pi. All right, let's go through one more. So let's do 4 sine squared of x minus 3 equals 0. And again, let's only do 0 to 2 pi. We're going to add 3. We're going to divide by 4. We're going to square root. Now remember, when you square root, we now have two answers. We have positive root 3 over root 4, and we have negative root 3 over root 4 is 2. So we're going to go look on our chart for all of the times, because it's sine, we're going to go down the sine column, and we're going to look for all of the times that we have either a positive or a negative root 3 over 2. So the first time is at pi over 3. And we're looking positive or negative, then we've got 2 pi over 3. 4 pi over 3. And maybe you're seeing the pattern that they're all over 3. And then 5 pi over 3. So remember that when you're square rooting, you square root the top and the bottom, but also that it's a plus and a minus.